Hello there. Today we'll be doing number 54 of Neetcode, copy list with random pointer. This is a very interesting problem. I highly recommend doing this problem because there is some learning to be done. So, some observations. So, what we're trying to do is copy a linked list with a random pointer. So, the first thought is, can we do this in two passes? Can we copy the node first, the next node first, and then copy the random pointer? Or can we copy the random pointer and then copy the next node? Because that's the first thought. Like, you can, let's try it. Let's see what happens because we know we can't do it all in one pass because we cannot copy a random pointer to something that doesn't exist yet. So we're going to separate the process, see if it's possible. So we try the random way, but the random way points to a null. Like, we don't know where it's going to point. And so it's not a cycle. Like, we're just going to be like in the middle of nowhere and we can't go forward anymore. So that's observation number one. And then observation number two is that we try, oh, that's not actually observation, no, yeah. Let's do observation number 0 first. Observation 0 is that cannot do one pass. One pass for random and next because random does not exist yet. So we try to two pass and the random doesn't work, and let's try the next. Yes, next does work, but what happens is that we have to go through, once we finish the next node, once we reach the null, we have to go through a whole list again, but this time we have to first find where the random is pointing to, then go through an entire linked list from like here to all the way to the end to find out, like which node is it, to find the same ID. And then, let's say for example this one's pointing this way. We have to start from the beginning and just find out where exactly is this, and then find that exact ID so that we can match the random pointer. So that will take n times n because we have to go here and then we have to check the entire list for the same item again in the next pointer, and then once we find it, then we can point it to the item. But that will take a very long time. The third observation is, why not make a hash map? Like, let's do two passes, but this time we're just going to get all the data because the problem was that we did not have the data. But once we do, can we just set the next and random pointer with a hash map? And the answer is yes, because the hash map creates a separate layer of pointers to the exact location, and we have the exact pointers to each object, and we can link them to the next object because we have the pointers to next object for random and for next. So we can point at all these things at the same time. So let's do that. Let's use hash map. We also want to set hash map to none at none because we need that to, for instance, if we have an issue where there is a none object. So current equals head, and let's move on. So let's fill in this hash map. So hash map at cur is equal to node dot cur dot val. So this current node has another, we can use this node as a way to access another node. Think about it as like taking it, throwing it into an object to point it at another node. We basically got a third piece to our node class, right? So then cur equals cur.next. Then we're done here. We have created our hash map. So what we need to do now is set these pointers, like hash map at cur. They do not point to anything yet. So set the next pointer to hash map at cur.next because that's the pointer to the next item. And we're gonna set the hash map of cur.random to hash map cur.random, because that is the object that we're going to point to, and that's exactly the pointer that we need to point our object to. That's the new object that we created. That's without these pointers from the linked list. Rather, we've got from our hash map. Then we set cur equals cur.next, and with that, once we hit the end of this loop, we have connected all the linked lists together using our hash map, and we can return hashmap.head, which has a pointer to the head object of our new nodes. And so now let's run that code and submit this particular problem. So let's click submit, and there we are, answered. So I'm really glad we did this problem, because we learned a lot here about how to use hash maps and linked lists and put those two together. It's like before you do it, it's very confusing, and like, how does the hash map, how do you use the current node, what do you point to, how does this help me? Like, we have no idea how the hash map was supposed to like connect all these items together. But after learning it from a Neetcode video or from a discussion section, we go like, okay, a hash map, very easy. We're basically creating a pointer to the new node object. And each node object is equal to the current item except for next and random pointer. But we have all that pointing using our hash map, and saving all those locations of our new nodes. And we can now point to those objects easily because we have all those objects using cur.next and cur.random. So that's how you use hash maps in linked list objects. And of course, there's more practice. With more practice, we will be able to use this in more situations, and we'll be able to, use these in our interviews and even at our jobs eventually. So this is great. So if you have any questions, please comment below. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. And that is all. Have a good one. I'll see you next time.